All right, so this is the Unit 4 review. Like I said in the other units, this is not perfect. It doesn't have everything that we did in the unit on it, but it does have most of it. I would suggest going and looking at the review guide on page 247 as you keep studying, but hopefully this kind of just is a good refresher of the things that we did. So Unit 4 had a lot to do with confidence intervals, but we started with the central limit theorem. And the central limit theorem tells us that a population of any distribution, as we take more sample means, our data will become more and more normal. So if you think about any sort of distribution, it does not matter what it originally looked like. When we find those sample means, right? If I do a sample size of like 10, it's going to be a little bit more spread out. It might be hard to tell that it's normal, right? It's not a huge sample size. If I take one of, let's say 50, we're going to see that it gets a little bit more normal looking. It still might not be perfect, but it's going to be more normal looking. And then if we took one of like 1,000, ran out of room, we would see that it's really taken on a normal shape. Yeah. So the first thing we talked about was how this affects our normal distribution. Remember, your population mean and your sample mean are the same, so that doesn't change. The only thing that really changes here is our standard deviation. So anytime we're solving, our standard deviation is going to change. And all it does is we take that standard deviation and divide by the square root of the sample size. So if we remember back to Unit 3 was a lot of that normal distribution. We did a little bit here, just particularly when it had to do with a larger sample size than 1. So if we look at this first example, yeah, the first question says, if a woman driver is randomly selected, what is the probability she can reach the pedal if the pedals are 34 inches away from the seat? So when you're just talking about one person in our sample size, we're doing our normal CDF how we did in Unit 3. Yeah, so we're considering, right, if our mean is 36 inches and our standard deviation is 1.2, we're considering 34 to be over here, and anyone taller than 34 inches will be able to reach the pedal. So we would do normal CDF from 34 to the rest of the graph. Our mean is 36 and our standard deviation is 1.2. Because we're only talking about one sample size, none of that is going to change. So if I hit second vars, normal CDF, I'm going from 34, 1e to the 99, 36, 1.2. So when I paste that in, I get a probability of 0.9522. So what changed in this unit is that next example, and that is the probability when the sample of 30 women. So again, we're still doing the normal CDF and really not much changes except for our standard deviation. So all of this is going to stay the same. And then just this last part, right, we're dividing by that sample mean. So when we look at our calculator, all of that information is staying the same. Oops, that's not what I wanted. All I'm going to do is take that last value and divide by the square root of 30. And then that gives me a probability of 1. All right, so then we started talking about our confidence intervals. Yeah, we had 2 types of confidence intervals that we did in this case. We did our proportions interval, which is our 1 prop z, right? That was when you were given a percent or a proportion, like this many out of this many people. And remember, you're going to be given a formula packet. It's the same formula packet that's in the front of your workbook. So all of this stuff is included in that formula packet for you, including your conditions that you check. And then remember, we learned how to solve for the sample size that we would need using both of those n values. So we'll kind of look at how we use all of this stuff now. So the first example, how many people would you need to survey to estimate the proportion of people who subscribe to Netflix and Hulu? So So again, because I'm looking for, I'm looking for how many people, I'm going to use one of these two formulas. And it just depends if we're given a recent p-value or not, if they've estimated the proportion or not. So if you look at part A, it says assume a recent survey suggests that it's about 24% of adults. So then because we're given a percentage, we're going to use this first formula. So it said we wanted a 95% confidence. So that tells us our Z is going to be 1.96. Our proportion here is 24% or 0.24. Remember, Q is just the opposite of P. So if 24% of people do, that would mean that 76% of people don't. So our Q value is 76. And then it said it wanted it within 3 percentage points of the true proportion. So that means that our E value is 3%, which we write as 0.03. Yeah, so we're just going to put that in our calculator and allow that to solve for us to figure out what that sample size is. So I'm going to multiply 1.96 squared times 0.24 times 0.76, and then divide that by 0.03 squared. So I get 778.56. Remember, your sample size always has to round up because I can't ask set 0.56 of a person. So to be accurate enough, I would have to ask 779 people in this case. So now the next question says that assume we have no prior knowledge. So that means that we don't know a proportion to use. So we're just going to use this equation instead. And we're going to use 0.25 here. Nothing really changed in terms of our information. We're just not using our P and our Q values. So our Z squared is still 1.96, and then times 0.25, and then over 0.03 squared. So when I solve that, 1.96 squared times 0.25 divided by 0.03 squared, I get 1067.1, which again, we still have to round up because to get accurate enough information, we have to ask at least this many people. And since we can't ask 0.1 of a person, we got to round up. Yeah, so those formulas just depend on what information you're given. They're both finding the same thing. They're both finding sample size. It just depends if you know the proportion or an estimated proportion or you don't. And that has to do with anytime you're working with a proportion. There's a different in value when we're working with our mean and our standard deviation. All right, so if we look at our next page, yeah, this all goes off of our proportion information. So if we wanted to keep that stuff kind of showing, this is a proportion questions, right? It says out of 850 people, 487 of them said they watch sports on TV regularly. So anytime we're given a blank out of blank, we know we're working with a proportion. So we're going to do a 1 prop Z interval. So the values that we know, our in value is always your total. And then our X value is the blank out of blank. So 487. If I want to find P, I don't necessarily need it to run my interval, but sometimes we're given P. Remember, if we're given P, we can find X by doing N times P. But we can also find P if we want to do X divided by N. Not entirely necessary to know P, but it is important that you know how to find X. So if I do 487 divided by 850, I get 0.573 as my P value. And then I want my confidence interval to be 0.99. So then I have my conditions here that I can check, that it's a simple random sample, that n times p is greater than or equal to 10. Remember, n times p is just x, so if you know that x is 487, you know that's greater than or equal to 10. N times 1 minus p. So here, you may need to know what x or what p is. You also know out of the total 850, if 487 of them are part of your proportion, the other piece is not. But if I plug in 850 times 1 minus 0.573, I get 850, about 362.95 or 363, which is well over 10, so we know that that is fine. And then our last one, we're checking that independence. So we're checking that if I have 850 people and I add a 0, it seems reasonable enough to assume that there are more than 8,500 people watching TV regularly. All right, so to find my confidence interval, right, we go to stats test 1 prop z. Remember, that's the main thing that's not on your formula sheet, is where to find things on your calculator. So if you struggle with that, I strongly suggest using that note card to write that kind of stuff down. So if I go stats test, and then I'm going down to letter A, 1 prop z interval, my x value is 487, n is 850, and I'm running a 0.99 confidence interval. So then when I hit calculate, I get 0.529 to 0.617. So then we write our confidence interval statement. We are 99% confident. Hopefully I spelled regularly right. Looks like it. Okay. So our confidence statement looks something like that. So that's our 1 prop z interval. So then the other kind of confidence interval that we did was our t-test, or our t interval. Yeah, that's when we're given a mean and a standard deviation. So again, here's these conditions. This will be on your formula sheet. How to find the n value when you're doing a t interval is here. So let's look at some examples that go with that. So how many people, right? How many people, that tells us we're going to use that n formula, would you need to survey to correctly estimate the mean cost of a car? The mean cost is currently this and the standard deviation this, and I want to be 99% confident that the error is within $500. So our n, we need to know z, our s, which is our standard deviation, and then our error. So we don't need all of the information that they gave us to get our n value, just some of it. So remember, we looked at that table before. Yeah, if we want to be 99% confident, we use the critical value 1.96. So we would have 1.96. Our standard deviation is 3,500. And then we want our error to be within $500. In this case, our error is not a percentage, so we don't turn it into a decimal. Our error is actually an amount when we're talking about these on a t-test. So I'm going to do 1.96 times 3,500, divide that by 500, and then square that answer. So I get 188.23, and then remember we always round up. So we need 189 people. Yeah, so that's the n value that we use for our t-test. So now let's actually practice running a t-test. So if we want to keep kind of those assumptions there for us to check, that can be helpful. There's kind of two different types of t-tests that you're going to see. One of them outlines exactly what the mean and the standard deviation are. The other one gives us a table where we'll let the calculator actually find the mean and standard deviation for us. So in our first example, a random sample of 200 women, so N is 200, found that the average cost of a wedding, average cost is our mean, $23,000, and a standard deviation of 3,600. We want to be 90% confident to find the average type of or cost of wedding. So because we're given a mean and standard deviation, we know we're running a t-interval. We're running a simple random sample. Our N value is greater than 30, right? 200 is greater than 30, so we're good. And then we want to know that our N value, right? It's reasonable to assume that there are more than 2,000 women that have ever gotten married. So that is our test of independence. So then we'll run our confidence interval. Again, this is how we find it on our calculator. That will not be given to you on the test. So we go stats, test, down to number 8 is our t-interval. We're doing stats. We're given statistics that we want to type in, not data. Data comes from a list that we would type in. So our mean is 23,000. Our standard deviation is 3,600. Our N value 200. And I want to be 90% confident. So I get my confidence interval. Okay, so then we can write out, interpret those results. We are 90% confident. All right, so there is one type of t-interval that we could be solving. The other type of t-interval, it's no different in what we're doing or what information we need. It's just what's given to us, right? This first example gave us a mean and a standard deviation. This second example is giving us a table of values that we're going to have to then figure out for ourselves. So that means we're going to type all of this into list 1. So I'm going to pause the video so you don't have to sit here and while I type it all into list 1. I would also, pause the video so you can type it in yourself, but we go to stat, edit, and then we're going to type everything here into list 1. So go ahead and do that and then unpause the video. Okay, so hopefully you typed all of these values into list 1 carefully. I hope I did too, to make sure that we get the right answer at the end. So we're still doing a t-interval because we're given data that we can find the mean and standard deviation of. Remember, if you're interested in finding the mean and standard deviation yourself, you can always hit stat, go over to calc, and then it will calculate the mean and standard deviation if you're interested in knowing that before you get started. But we don't really need that to run our confidence interval. So let's check our conditions first. We have a simple random sample. Our N value, we have 40, which is greater than 30. So we're good in our sample size. And then it's safe to say that there are more than 400 people that are checking out at Target ever. So I think we're good there. There are definitely more than 400 customers of Target. So if I run my confidence interval, I'm still doing a t-interval, but then I'm going to select data and I'm going to tell it to pick out of list 1 because that's the list that I'm running. And then I'm running a 99% confidence interval. We won't change frequency. We don't want any number to be counted more than once, so we're good there. So we'll hit calculate. And now it tells us the mean was 6.65375. It tells us our standard deviation. And it tells us our N value, which we already knew. So that kind of stuff we could fill in after the fact. Or you can do that 1-bar stats and figure it out yourself beforehand. So I get that my confidence interval is 5.65 to 7.66. All right, so then I interpret my results. Again, how we interpret our results does not have to be exactly the same. It just needs to encompass the interval and then the context in which the interval falls into for the problem. So that was the main stuff that we did in Unit 4. Again, I strongly suggest going back and looking at that review guide to make sure that you've practiced enough and that you're ready to go for your final.